So basically, I mean, just like what my Calc 1 reference last week, it was like, well, what do you do in Calc 1? If you're ever in doubt, take the derivative, set it equal to 0, and solve. It's the same idea here. You have a system, get it in reduced row echelon form, and see what you have. If it's a trivial solution, then you're looking at an independent system. If you have something that's not trivial, so something that, I mean, it could be something equal to a particular vector, or it could be a general vector. So it's something in, you know, if it's actually dependent on other vectors, then I think you've answered your own question, right? Is it a dependent system? I don't know. Well, it's dependent on x5, so I think maybe. You know, that's the idea here. All right, so do what you did on the previous pages. If all you get is the zero vector, it's independent. If you give something else, it's dependent. Right? So very, very easy. If you have a free variable, it's dependent. Yeah. So literally anything except for a column of zeros is going to be dependent. And really, when you think about it, like an equation, you know, just a simple linear equation from algebra 1. I mean, how often did you have something like, here, graph this line, x equals 2, y equals 5. There's always y in terms of x, because y was dependent on x. So don't make this more complicated than it needs to be. It's basically saying, like, if your answer is an equation of some kind, it's a dependent system. If it's just 0, then it's not. All right, so here's a case of dependent. Previous one was the trivial solution. Here it's not. You got something other than 0. I forget where I got these from, because I definitely didn't type these myself. But I remember thinking, I don't feel the need to do basically everything we did in the previous section just to illustrate this point. Okay? Because you're looking at, you have, you know, it's asking whether or not the 2 by 2 matrices are linearly independent or dependent. So you just do the same thing and see what you come up with. All right. So it turns out it only has a trivial solution. If you went through the process, you would only get C1, C2, C3 equals 0. So therefore, it's independent. If they ask a yes, yeah, because you want to make a determination of whether the homogeneous system has only the trivial solution. That's a good point. Did I type that? Hopefully I did. It's probably in that blurb that I said don't even bother reading because it doesn't matter. Right. Okay. Yeah. So here it's right here. Form the equation which lead to homogeneous solution. I don't know. I feel like there's a grammar issue there. Form the equation. I don't know. Whatever. So I'll take an edit on that. All right, so yeah, it's the same idea. I mean, I could just grab. I mean, this is really the same question, right? So you're going to create a linear combination to make a determination of whether you're dealing with a dependent or independent system. Now, actually, if you look at it, just to cut out a little bit of the fluff, because you really could go through the entire process of, you know, actually creating the linear combination, doing the multiplication. But really, when you think about it, the columns, and we already knew this, but I'll just state it explicitly just so we have it. The columns of your matrix are the vectors. And in fact, that is the definition of a matrix. So the columns of a matrix make up a vector, are made up by vectors. So what are we really doing except for taking the columns of the matrix, which are the individual vectors, reducing that, and seeing if we can basically get the identity matrix. All right. So if we get ones down the main diagonal, zeros everywhere else, then you're dealing with something that's linearly independent. Because that's the only way that you're going to get a solution. Yeah, that's the only way you're going to get a solution where it's all zero. Everything else would have to be I'm just making sure I'm not lying here, because when I give shortcuts, I want them to actually work. It's like it's a personal preference, basically. I like what I'm saying to make sense. Uh, yeah, I think, yeah. Just don't forget to get your zeros in there. All right, so I'll actually take you through example 2 real quick, just to verify this. Because really the idea is that it should be a quick take a look in the calculator and see what you come up with. All right, so I'll put it in as a 3x4. I'll do it as homogeneous. Even though the zero column is going to be irrelevant, I'll put it in anyway. Three, 1, 10. All right. Good, 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 good. All right. RF this bad boy. Yeah, so that zero column would be irrelevant because it's homogeneous. Yeah, so okay. Because I want to make this as much of a gimme as possible, where it's like on the test when it says determine if something is linearly dependent or independent. I want it to be a quick yay or nay kind of situation. I don't want you to have to do a ton of work. I always like to throw a question or two on the test where it's like you just have to show up and you'll get those right, and then you'll earn your keep on some other questions. So I'm trying to kind of make this into one of those. Yeah, I think we're good because this tells you everything you need to know. So what I would recommend on the test is put this matrix down, circle the things that make it not an identity matrix, and say dependent. Smiley face. Right? Because the 4 and -2 are there, so they kind of pop out at you as like, okay, this is definitely a dependent system because of the 4 and -2, but also it's dependent because you have the 0 row. Right? If you have a row of all zeros, that means that there's a free variable. If there's a free variable, then obviously everything else is going to be dependent upon that free variable. Or the solution will be dependent on what that free variable is. The first thing I said was maybe true, maybe not. But the second thing I said is definitely true. The solution of the system is definitely dependent on any free variables, because if x4, for example, is 2, then your solution will be one thing. If it's 20, it'll be something else. Right? So it is totally dependent on any free variables. So that should actually jump out at you more so than anything else. The 4 and -2, those are great. Definitely implies a dependent system, but the free variable is your key indicator. Right? So be on the lookout for that, because it's one of those things when you see it, you just take a quick glance and you know you're good to go. Right? I'll do it just to say that I've done it, but I think you already knew this. I mean, you definitely already knew it. 3x3. So basically the same matrix without the 0 column. All right, gives you the same stuff. Actually, let me take this instead. All right, so you can get from this what you get from the one that also includes the zeros. And the reason why I show the approach involving the column of zeros is because if you're anything like me, you're one of those folks who screws up in the weirdest ways on tests. Like, I mean, you do a problem like 100 times, and it's not in a testing environment, you get it right 100 times. But when the piece of paper says test on it, for some reason, you start making all kinds of stupid mistakes that you would never otherwise make. Like if you fall into that category, then you're just like me. So you're all grown up. I don't know if that's a good thing. So I put this here because I'm worried personally that I would forget that there is a column of zeros. So I would actually I would actually use a matrix that has, even if it's like a 10 by 10 matrix, I would take the additional time to put in the column of zeros because I worry for myself that I would forget, you know, when I'm getting in the groove of things, I'll look at this and I won't be able to stop myself. I'll think that this is actually the last column. But it's not. There's a column of zeros implied or otherwise. So I do it anyway. If you don't want to do it, you don't have to, but if it might be, you know, kind of a quality control sort of thing. You know, if you find yourself making those weird kind of mistakes, like you never get 100 on a math test because you get half-point deductions like on every page for like weird nonsense, then you might be in that category. Okay, so anyway, I mean, you could do these problems, but I think it's all going to boil down to the same stuff. So I'll pop up an answer key. In all honesty, the answer key's already up, but I do want to refresh my answer key to make it coincide with the new packet. All right, so I mean, like I said, you can do them if you want. It's up to you.